Hello students, in this video we're going to look at problem number F2-8 from Hibbeler's Statics textbook, 14th edition. This problem deals with the addition of a system of coplanar forces. Now in a previous problem we solved for two vectors by using the triangle rule. In this case we can do something similar by using the triangle rule twice, but since we have a third vector, I think a better way to solve this problem will be to break down the vectors into their x and y components. So let's look at this problem. We are given a hook that experiences three force vectors. One is a 300 Newton force acting horizontally, that is along the x-axis. One is a 400 Newton force acting at a 30-degree angle from the x-axis. And one is a 250 Newton force acting with a slope of 3, 4, 5. Now we're going to talk about that slope, what that slope means in a second. Our problem here is to find the resultant force vector that results from these three force vectors. Now to make our analysis a little bit easier, I'm going to name these vectors. I want to call my 300 Newton vector A, my 400 Newton vector B, and my 250 Newton vector C. That way I don't have to keep repeating their magnitudes. If I want to find the resultant force vector, the easiest thing to do will be to break down A, B, and C into their x and y components. Now we already know that the x component will be the horizontal component in this figure. Since this is a two-dimensional system, I can set my y-axis to be the vertical component of this figure. So now all I have to do is to find each component for each vector. So let's start with the easier vectors. Let's start with vector A. Vector A is a 300 Newton force vector that acts along the x-axis. Because A is acting along the x-axis, then the entire magnitude of this vector will be its x component. Now, because there is no portion of A that's acting along the y-axis, then the magnitude of the y component of vector A should be 0. So we finish with A. Now let's look at B. B is a 400 Newton vector, acting at an angle of 30 degrees from the horizontal. Because we know the angle between the vector and the horizontal, we can find the components in the x and y directions by using sines and cosines. In this case, because my horizontal direction is adjacent to my angle of 30, then my x component of B should be equal to the magnitude of 400 newtons times the cosine of 30 degrees. This gives me an x component of approximately 346 newtons. Because the y component is opposite to the angle of 30, then we need to multiply the magnitude of the vector, 400 newtons, times the sine of the angle 30. Now we can solve this with a calculator. Sine of 30 is 1/2, therefore the y component of my vector B should be equal to 200 newtons. Now so far we solved for vectors A and B, but now we have to look at vector C. Vector C is a 250 Newton force, and we're not really given the angle of the vector, but we are given the slope of the vector. Note that for every 4 horizontal units, the vector will move 3 vertical units. This means that the vector follows the slope of a 3, 4, 5 triangle. Now, when we are dealing with slopes, we're not really writing down sines and cosines, but the theory is exactly the same. Remember that the sine of an angle is equal to the ratio of the opposite side over the hypotenuse of the right triangle. In this case, if we wanted to find the angle from the 250 Newton vector to the horizontal, then the sine of that angle should be equal to the opposite side, which is 3, divided by the hypotenuse of the triangle, which is 5. Because the triangle formed by the 3, 4, 5 triangle and the triangle formed by the vector and its x and y components are similar triangles, then 3 over 5 should be equal to the sine of the angle regardless of the magnitude of vector c. Similarly, the cosine of an angle is equal to the adjacent side over the hypotenuse. In this case, the adjacent side would be 4 and the hypotenuse would still be 5. So even though you don't really write down sine and cosine, using slopes to find components is the same as using your sines and your cosines. For the x component of our vector c, we will have the magnitude of the vector times the cosine of your angle. And in this case, the cosine of the angle should be equal to 4 over 5. Now there is something else that we need to keep in mind. Notice that the x component of my 250 Newton vector c will be acting along the negative x direction. Because it will be acting along the negative x direction, I do need to add a negative sign to my answer. This gives me an x component for vector c of negative 200 newtons. Similarly, the y component should be equal to the magnitude of the vector of 250 newtons times the sine of its angle, which in this case would be 3 over 5. The y component of this vector is acting along the positive y-axis, so there's no need for a negative sign here. This will give me a y component of 150 newtons. So we found our x and y components for all of our 3 angles. However, that's not really what the problem was about. We wanted to find the resultant force for all of these vectors. But now that we've divided everything into x and y components, the resultant force should be very easy to find. To find the resultant force in the x direction, we just have to add up all of our x components. Our x component of the resultant force will be equal to 300 newtons plus 346 newtons minus 200 newtons. The minus sign refers to the x component of vector c, which acts on the negative x direction. This gives me an x component for my resultant force of 446 newtons. The y component of my resultant force will be equal to the sum of the y components of my individual vectors. That is 0 plus 200 newtons plus 150 newtons. This gives us the x and the y components of my resultant force, 446 newtons and 350 newtons respectively. Graphically, we have an x component of 446 newtons and the y component of 350 newtons. We can find the magnitude of the resultant vector by simply performing a vector sum. In this case, the vector sum should be equal to the start, a vector that goes from the start of the 446 Newton vector to the end of the 350 Newton vector. Notice that this vector sum forms a right triangle, so we can apply the Pythagorean theorem to find the magnitude of our resultant force. The resultant force should be equal to the square root of 446 newtons squared plus 350 newtons squared, which is equal to approximately 567 newtons. We can also find the angle of that resultant force from the horizontal. Remember that the tangent of an angle is equal to the opposite side divided by the adjacent side. In this case, the tangent of our angle theta will be equal to the opposite side of 350 newtons divided by the adjacent side of 446 newtons. This means that we can solve for our unknown angle theta by finding the inverse tangent of 350 divided by 446. This gives us an angle theta of approximately 38.1 degrees. And that's how we solve a system of coplanar vectors.